Hi class, let's take a look at problem 26. Now on problem 26, I've provided the sketch of one period of the regular cosine function without basically adding anything else other than one period from the values from 0 to technically the values of 2 pi. Now the function that they want us to graph first actually has an amplitude of 3, and then we have a total of 4 units being added to every one of the y values. So our function is no longer going to go to from 0 to 1. It's actually going to go from 0 to 7. So all of these coordinate points that are your reference points are going to be modified. And what I did here is I included the basic reference points and also the vertical translation of the function. So we're not starting at 0, 1 because of the amplitude of 4 and the addition of, amplitude of 3 and the addition of the 4. We're going to start at 0, 7. So our function, it's actually going to do this. And all I want is a basic sketch. So in this case, our function, it's actually going to do this, going through those coordinate points, and then we only want one period of the function. Do label the coordinate points. I do want to see a basic sketch of the function going in this direction and then ending up at the 2 pi comma 7. Here I've actually introduced the actual sketch of the function. Here you can see, well, this is using technology, and I've also extended the function a little bit. But for our sketches, I just want to see technically the coordinate points that your graph is going through. And let me try to fix this one here. In this case, it's actually, our function is supposed to be smooth, and it's supposed to go through those coordinate points. Okay, so that's actually it for the first part of it, where they want a basic sketch of 4 plus 3 cosine of x. The second part, they want us to find the inverse. And as we find the inverse, we have to remember that your cosine function, it's not technically 1-to-1. So we have to pay attention about the range of this function, in this case from 1 to actually 7, because that's going to be the domain of the inverse function. So let me actually rewrite the function. So the function that they're asking us to write the inverse, it's 4 plus 3 cosine of x. So 4 plus the values of 3 cosine of x. Remember that when you're doing the inverse, you start with change y to f of x, or f of x to y. So this will be y is equal to 4 plus 3 cosine of x. And then technically you swap the values. So I'm just going to let y is equal to x. And in this case, I have that x is equal to 4 plus 3 cosine of y. And then we're going to solve for the actual y value. So minus 4 minus 4, which is giving us x minus 4 is equal to 3 cosine of y. And then we're going to be dividing by the values of 3. So our function, it's now going to be x minus 4 divided by 3. This is equal to cosine of y. And then we're going to take the inverse of both sides. So we're going to end up with the cosine inverse of x minus 4 divided by 3 is equal to the cosine inverse of the cosine of y. Remember that the property of inverses cancels your cosines. And then we finally have, in this case, the cosine inverse of x minus 4 divided by 3 is equal to y. So let me rewrite it as an inverse. And in this case, your inverse, we're going to have that y is equal to the cosine inverse of x minus 4 divided by 3. Or the inverse function it's equal to the cosine inverse of x minus 4 divided by 3. And then I'm just going to say that the domain, it's technically the range of the previous function. So from 1 to 7. So our final answer, and we do have to state the domain because technically your function is not, in this case, the original function, it's not 1 to 1. So when you're constructing a inverse, you have to make it into a 1 to 1 function. So in this case, what makes it into a 1 to 1 function is the line segment that is collected. Here you can see the actual graph of the inverse. And here's what I was talking about. Well, technically from 1 to 7, here's from 1 to 7. And notice that our domain is our range, technically from 1 to 7 of the original function. That's actually it for this one. The function is not asking us to state the domain, but we have to state the domain because, well, your cosine inverses are not are not going from negative infinity to positive infinity. That's actually it for this one.